Okay, I guess I'll go ahead and get started. I've got a raptor. Welcome everybody, thanks for coming to this presentation on database virtualization and how it helps improve application development performance. So my name's Kyle Haley. You can email me if you have questions at kyle@delphix.com. I also have a blog where I talk about a lot of things I'll talk about today, as well as Oracle performance and other things at kylehaley.com. So I work for a company called Delphix. At Delphix, we write software. The software enables Oracle customers and SQL Server customers to clone their databases in a few minutes, no matter the size, for almost no storage overhead. Now that might sound impossible, but we'll talk about that later in the presentation. So from my perspective, from what I see talking to companies in the industry, there's a problem in the industry, in the IT industry, and that problem is data. There's a recent CIO survey that asked CIOs about their projects, and they found that 60% of the projects, over 60% of the projects, are delayed and over budget. And of those 60%, 85% of those have delays because of getting data to the right people. So the problem we have is getting the right data to the right people at the right time. What does that mean, getting data? It means getting developer environments, it means getting them copies of the databases. And usually the longest yard is not so much setting up the development environment, it's getting copies of big databases. And what we see is this data flood. So everybody's talking about big data, but what if we just take a normal, regular production database, not my Apache logs on Facebook, on my regular production database? First of all, I'm going to have data guard. I'm going to want to be able to fail over. But beyond data guard, I'm going to need backups to take, backups for forensics. I'm going to need business intelligence, where I'm going to run my reporting databases, my ETLs, and I'm going to need copies for development. Where am I going to write my applications, where I'm going to QA my applications. And it's what we call the triple tax. Like I'm copying out on regular intervals full copies of this database, flooding my networks. Talked to one of our military branches, and at this particular IT center, that basically the network's unusable starting Friday night. They run backups the whole weekend long. It's a bit of a shame. As somebody said, I hope we don't get attacked on Saturday. So this presentation, we have three parts here. I want to talk about the problem in the industry, copying, cloning databases. I've got this guy lugging a suitcase because I got to copy these huge databases from one place to another. Then I want to talk about solutions, something called thin cloning. I get this guy on a mountain bike. So he doesn't have to move a suitcase from one spot to another, but he has to be dexterous. He has to know how to make these thin clones. It's not easy. And then we're going to talk about database virtualization, where it's just point and click. Everything's automated. And then if I have database virtualization, what does that do to my project development? It accelerates my product development. So I don't know if you can imagine this particular drawing, but I imagine myself as this little guy here. Last time I was a DBA, I spent half my time copying databases, and the business was constantly asking for copies. Like, I need a copy now. I'm like, well, that's going to take a while. And the business is like, what's wrong? You IT department, you guys are broken. From the business point of view, they don't understand what's going on in the DBA world. All they know is they have a business problem they want to solve, and they want to solve now. So it sort of causes problems. How many people in here are DBAs? How many people are developers? How many people are managers? So about half and, oh wow, okay, cool. Half and half developer, DBAs, and managers. So what's the problem? I've got a production database. This is the heart of the business. This is where all financial operations are taking place. If it goes down, it can mean millions of dollars an hour. So at all costs, I want to protect that production database. But I'm going to need to run reports on it. Now, reports are heavy-hitting queries, right? What about the manager, the VP, the CIO that wants to run some cool new queries he's got? They're ad hoc queries. Who knows what they're going to do for performance? I don't want them running those in production. So we have to get a second copy of the database. It's almost like a requirement. What about QA and user acceptance testing? What about new applications that are going to run on that database? They have to be QA. I need a copy of the database if I'm going to QA them. I'm going to need one for UAT, one for QA, maybe another one for a couple of QA suites. Well, where do those applications come from? I got a group of developers that needs to write the applications. Well, they need a copy. Now, if I ask the developers how many copies do you want to share one with the rest of the guys in your team, or do you need one for yourself? I need one for myself, of course, right? This is one of my favorite examples. So CERN is the European Nuclear Research Institute. They have their biggest database is a 145 terabyte database. It's growing at 75 terabytes a year, and there's a couple of dozen developers who all want their own copy. It's not going to happen. So here is a cycle that we see in the industry. I don't know if this is familiar or if you guys run into this per chance, but what I see over and over again, I see IT budgets being constrained. And what's the first thing that gets hit when an IT budget's constrained?
QA.
What's that?
Testing.
Testing. Hardware. So I hear hardware. I hear storage all the time. Can't we cut up? You guys need another copy? Come on, we need to reduce our storage. I can't give you another copy because that takes up too much storage. So as storage gets constrained, what happens? I can't provision the environments my developers need or that my QA needs. So what happens? I get delays on my applications. They can't write them as fast as they want, as they should. Well, what happens to the business? The business can't get the applications to generate revenue. Well, less revenue means what? More IT constraints. So it's a vicious circle. So here's talking to different customers and companies in the industry, these are some of the things that we're seeing, problems that we're seeing, and I'll go into each of these in a little bit of detail. But I like to look quite at the top. If you can't measure it, you can't manage it. So some of these problems I'm going to go into, some people might be able to say, yes, I know that's a problem. Some people might be able to say, well, I don't know if it's a problem. Well, if I don't know if it's a problem, I can't manage it, I can't fix it. So the first one is inefficient QA times. So talking to, for example, a customer, Presbyterian Health, when they do a QA cycle, they spend 96% of that QA cycle building the QA environment and 4% running that QA suite, which means for $1 invested in QA, only 4 cents is actually doing actual QA work. The rest of it's infrastructure costs. So it's inefficient QA. Does this ring a bell to anybody run into this? One person, anybody else? I see this over and over again, where people spend a lot of time. Well, there's also a lot of politics here. What if I'm a QA manager, right? I want a big QA team, right? I want power, so I don't want to tell anybody how inefficient my QA system is. Does that ring a bell anywhere? Anybody ever worked at Oracle? It's all about power. I want more people on my team. Second thing is QA delays, because it takes a long time to build these things. If I finish a sprint or a code freeze, I want that QA, right? I want to QA fast. But I got to build that QA environment, so I have to wait. By the time the QA suites run, a bug that might have gotten introduced back here has a lot of dependent code written on top of it. When I find that bug, I got to find all the dependencies. This is going to cost me more code rework. And there was a similar book in 1981 by Barry Boehm. It's the software engineering economics book. He introduced the IT world to the idea that the longer it takes to fix a bug in the software development lifecycle, the more expensive it is to fix. Makes sense. But not only is it more expensive, it goes up exponentially. You know, what's the cost of fixing a bug in development versus the cost of fixing a bug after production? It's huge. The third thing we see is delays in development teams. I was talking to eBay. This is way back before they bought Delphix, but talking to eBay, and these guys, a couple dozen guys are sharing one copy of the production database, big database. And I was like, well, what happens when one of those guys wants to change the schema or add some metadata, maybe add some more data to the database? What happens? Oh, well, we've got a system for that. They submit the code for review, and we spend 1 to 2 weeks reviewing the code, and then they have their change. Well, I don't know about you, but man, I was a developer, and I was writing some code that needed a new schema, needed a new table or a column or something, and I had to wait 2 weeks to get it. I mean, what do I do till then? I'll watch a few more kit videos than I would have otherwise.
I can has cheeseburger.
What's that?
I can has cheeseburger.
Yeah, exactly. Are your developers working? Yes, they're working. What are they working on? One of the big problems with this, though, is if I have a bunch of people using this system, this is a big database, and I want to refresh it, I've got to get everybody on board, and they probably have some stuff in here they want to pull out. So I've got to get ready to pull their changes out, say I can stop using it, so I can refresh it. It's a big database. It's going to take a while to refresh it. I also have to get everybody on board that you can spend this much time not using it. Well, what happens? This thing gets to be like, how old? Anybody, what's their oldest development database? 6 months, a year?
6 months.
Anybody have one older than a year? This stuff gets old. Older than a year. A couple older than a year. So that data becomes old and unrepresentative. But the big thing is frustration. Have you guys ever run into this frustration business? Where developers like, I want changes faster? Okay, last time as a DBA, I was the gatekeeper for changes in the development database. So schema changes came in through me. I was fast, I'm a fast DBA, right? But so it might take me an hour, 2 hours to get a change in. Well, guess what? Young guys, when they're 22 or something out of college, man, they're faster than I am. I'm 47. And they're like, I can't wait an hour or two. My development team unilaterally decided to dump the schema, the structured schema we had in Oracle database, and make something called an entity attribute value database. We also call it the stuff table or the long skinny table. So if I take a row from a schema, each field in that row gets stuffed as its own row in a stuff table. So no longer is a field called employee name or last name or first name, it's called the field, right? So your query is like, select the field from the stuff table, where the field equals something, where the field equals something. I can't read my code. And performance is atrocious. There's a pretty funny blog post by this guy, Mark Fowler. It's like, he proposes that one of the main reasons for the rise of NoSQL is not because it's so great. It's because they look at us fuddy-duddies, DBAs, and be like, these guys are bureaucracy. I'm smart and young. I'm going to go around them.
Question, please.
Yeah.
If they're transforming their table, like they have different columns to just rows now, where each column is now represented by a row, the query has to change, right?
Oh, yeah, queries are unreadable, yeah. Radically different.
It's very
So
difficult.
They can do stuff, but eventually they have to change it. What goes into production is not what they built around that row-built table, right?
You just tell the DBA to make the database faster.
Exactly. For example, in my experience, we went to production with that EAB. I told them not to. Performance was atrocious. But after that, it's actually after they stabilized what they wanted, we restructured it back into a structured schema. And like, the top activity page in Enterprise Manager? Anybody know that page? It shows average active sessions, this load. Actually, I designed that page. Anyway, but this is before I designed it in OEM. I had my own average active sessions monitor. EAB schema, the thing was just like loaded like this. We put it into a schema, structured schema, boom, almost zero. I mean, night and day. But for me, this is a real problem that I've run into with developers. So what's the other strategy? If sharing a database is causing developer frustration, what do? Well, we can't give them all a full copy because it's too much resources. We give them subsets. We slice up a little bit of production and give it to all the developers. They each get their own copy. But one of our companies that we're talking to, Royal Bank of Scotland, they said that other DBA teams, 50% of the time is spent making database copies. But they're not full copies. They don't have the resources for full copies. So what do? They make these subsets. Well, if I'm pulling data out of production, I better pull the right data out. What if I pull last year's data and my queries are running on this year? Then those queries are not going to return any rows in the application. I get to pull out the right data. Not just the right data, it's got to be coherent. It's got to respect referential integrity. This stuff's a pain in the neck. And they spent a lot of their time just fixing these scripts that kept breaking. But the best thing is what happens after I write my application on subset and I QA it on subsets and I put it in production. Anybody got any ideas? Anybody seen this happen before? It hits the wall. Like these queries have never seen a full production set of data. First of all, they're going to run slower, not all the time, but sometimes they'll run slower if they're not using the right indexes. And not only that, the range of data is greater. There might be data ranges that code's never seen on the subset. It hits to some new value that's never seen before and it breaks. So one of the customers we're talking to, StubHub, they used to use subsets. And they said about 20% of the bugs in production were because they're using subsets. And then the most pervasive thing that I see is it's just a slow environment builds. If I'm a developer and I want a copy of a database, well, first of all, I don't even ask. Am I going to get a copy if I ask them, hey, DBA, I want a copy? I don't even ask.
I'm busy.
You serious? You need a copy of the Virtual Database? But what happens? I submit a request to my manager. Here's my business case. Here's why I need it. Can I get it? Right? It's going to sit on the manager's desk for a while. And he's going to make a decision one or the other. If he decides yes, well, what happens to it? It goes to DBA. And the DBA has to go to the sysadmin. I need a machine to put this thing on. The sysadmin says, I need disk for this thing. It's a lot of disk. Maybe I don't have it. I got to order it. I mean, each one of these pass-off takes time. We talked to one large global bank. They say that average time is between 3 to 6 months to build one copy of the production database for development teams. Now, how about there's faster ways to do it than copying, right? Copying a big 10 terabyte database from one place to another takes a while. Well, what about using file system snapshots? I talked to Electronic Arts. They use NetApp. NetApp has file system snapshots. That's how they make their databases. So I was like, how long does it take you to make a clone? It should be like this, right? The guy's like, 4 days. Like, 4 days? Why 4 days? He's like, well, you know, I've got to, it's all this is change requests. I submit a change request to the DBA. DBA submits a change request to the system admin. He submits a change request to the storage guy. And it takes about 4 days. I'm like, he's like, if I had them all in the same room, maybe I could get it done in 4 hours. But I don't. And that's Electronic Arts. I talked to Reba. They do the same thing. Reba uses file system snapshots. It takes them 3 months. Using file system snapshots still takes them 3 months to make a copy. So this is the world we end up in. I'm a developer. I want a copy of the database. DBA is like, thank you again, buddy. My motivation as a developer, my passion as a developer. I don't know about the DBAs can emphasize with this, but I've been a developer, and I'm like, geez, I'm not really excited right now. And then we only have so many resources for the projects we want to do. We're talking to the state of Colorado. They signed off with the state legislature, signed into legislation 100 projects. They've only got their infrastructure to do 3. These development environments are big, especially mainly because of the databases. So I've got all these projects waiting. What does that create? Bottlenecks, creates delays. Anybody know Hot Sauce Conference, Method R, Terry Millsap? It's like the geekiest Oracle conference out there. I took my little boy there when he was 1.5 to introduce him to Oracle. And here he is at 4. He made a nice little bottleneck for me in his bedroom to illustrate the point. So here's the problems that we've seen. Inefficient QA, where I'm spending more of my time building the QA environment than actually running QA. QA delays, I find bugs late, I've got more work to do later. Sharing databases and development teams, causing bottlenecks, developers have to wait for each other. Using subsets, creating bugs that end up in production. And then just slow environment builds, really slow environment builds that just kills everybody's motivation, creates a culture of no. But let's step back and look at what we're doing. What is this process that we're looking at? If I have 3 copies of the production database, say, QA, development, UAT, across these databases, 99% of the blocks are going to be identical. It's sort of a waste to keep copying from place to place to place. So somebody had a bright idea, right? Maybe there's another way to do this. What if we could take all those duplicate blocks and share them with the clones? And if a clone made a change to a block, keep that change block private to the clone. Sounds like a great idea, but how are you going to do that? I'm not a file system expert. I wouldn't know how to code this stuff. This is like computer secret sauce to me. I code a lot. I have no idea how to code this. So there are technologies in the market that we could harness to do this. So I'm going to talk about these 4 technologies. So anybody here at CloneDB? One guy. Anybody using CloneDB? Okay, we'll talk about what it is. Pretty cool. And then we can look at storage array vendors, EMC, NetApp, ZFS, and see how we can take snapshots and share duplicate blocks on these technologies. So what does CloneDB do? I take an RMAN backup as copy, so these are the data files. RMAN has 2 methods. You take the RMAN backup and slices and dices and shoves them in these files that are unreadable. Or I can take a as copy, and I get a copy of my data files. Then I'm going to map, for each one of those data files, I'm going to map a sparse file on top of it. So sparse file is basically an empty file that looks like a big file, and it maps to this RMAN backup. When I start up this CloneDB instance, it's going to look for data blocks here. In the beginning, it's empty, so it's not going to find them. It's going to come back and say, I didn't find it. Then it's going to go back and look at the RMAN backup, and then it'll find it. Now, if the instance changes some data, it doesn't stuff it in the RMAN backup, it stuffs it into the sparse file. So the sparse file starts to get bigger and bigger as it's used. Now, what's cool about this is I can start as many clones as I want, and they can all share that RMAN backup. Pretty cool. So if you remember one thing from this presentation today, this is probably it, because when I get a presentation, I like to walk out and have some new tool in my pocket that I can use right away. I don't need to buy any specialized storage. I don't need to buy a new Oracle license or anything. And this is how you do it. As far as I know, it's not documented by Oracle. You need 11.202 or higher, and you need to compile your Oracle binary with DNFS. You do that by going to Oracle Home RDMS Live. You can make the binary, give the flag DNFS on, and then you bounce your database. And then you need to get on MetaLink. There's a secret Perl script called clonedb.pl that's available only on MetaLink. And it takes two arguments. It takes the init.org, the source database, the original database, and an output file name. And before I run it, I need three environment variables. I need to tell it where is the RMAN backup located, the directory it's in. I need to tell it where it's going to put the sparse file. Now the really weird thing here is this sparse file has to be on NFS. Oracle's going to access the NFS. Sounds bizarre, but that's how it works. And then the name of my new database. Creates a script, and then I can run SQL plus the sysdba, the script, and in a few seconds I got a new database, probably around 30 seconds. What it does is it starts up the database no mount, it recreates the control file pointing to the backup data files from RMAN, and then the secret sauce is this package procedure that maps the sparse files on top of the RMAN backup files, and then it does open reset logs. If you want to try this out and want more information, Google Tim Hall and CloneDB. He's got the best blog entry I know on this stuff.
So with this approach, like if somebody's making, like two different developers are making changes to the same database object, let's say, okay? I mean, database object also, would you count that as data? How do you reconcile the differences? How is it different?
So if I modify an object, like add a column or something, that's stored in data blocks. Those data blocks are only going to be visible to that clone. This guy over here is not going to see that changed data block.
Let's say that he's changing something that's inserting into that table, okay?
And
he's not aware of that new column, okay?
This guy won't see the new column. If this guy changed it, he's better be aware of it.
They have their own sparse files.
So that's kind of
They've got their own sparse files.
Right.
Yeah. So now I'm going to talk about storage arrays. Let's first talk about EMC's got something called copy on first write. The idea here is if these green things are data blocks in my file system, and I have an active file system using these data blocks, I can take a snapshot. So snapshot's going to be a point-in-time version of these data blocks. So the question is, what happens when I take a snapshot and the file system changes a block? What's going to happen is I'm going to copy the old version of the block to a new location, update the pointers in the snapshot, and then the new file system can write out the change. And what that means is, for every write here, I do a read and two writes. I get a non-negligible performance hit by using this stuff. So this is EMC copy on first write. You have a write penalty, slows you down. You can only do 16 snapshots. Sounds like a lot, but man, that's nothing in my world. And you can't branch the snapshots. You can't take a snapshot of a snapshot. How do we get around some of those limitations from EMC? You can go to NetApp. NetApp has something called Waffle, or Write Anywhere File System. EMC has something new called Redirect on Write, which might be available. It's not available on Symmetrics. It's available on some of the new VNX arrays, but you have to look into to see whether it's available or not. And here's the idea. I don't know how it works. This is private to NetApp, but there's the basic idea. We have a bunch of data blocks. It's almost like an Oracle index, like the leaf nodes. And these are like the branch metadata that describes where the leaf nodes are. So this metadata describes where on disk the blocks are that make up a file. If I want to modify a data block, I don't actually go in and modify the data block on disk. I allocate a new block and I write the new contents in that new location. So I never overwrite old data. What about the metadata that pointed to the old location? Same thing, I don't overwrite the metadata block. I allocate a new metadata block with the new pointers to the new location. And this ripples up the tree. What does that mean is that I have that old copy of the root block. It points to the file system as it was at that point in time, which means taking snapshots is instantaneous. I just need a copy of that one block. But we're still limited. We still can only take 255 snapshots. But it does allow us to break through the barrier of branching. I can now take a snapshot of a snapshot. How do we get unlimited snapshots? We can look at ZFS. So ZFS is similar to NetApp. Same sort of idea. I have my data blocks, metadata. But with ZFS, the way they've architected it, snapshots are unlimited and instantaneous, clones are unlimited and instantaneous, and branching is unlimited and instantaneous. It's pretty awesome. But does anybody see any problem, any performance risks using this kind of technology? If I change one block here, and then I do a sync write, say I want to flush it to disk, how much writing am I actually going to do to disk? Am I going to have to write all this junk out? I mean, in this particular graphic, I change one block and then I have to write 4 blocks out, right? Sounds bad. But actually, that's not the way it works. It's sort of like Oracle. There's this thing called the ZIL, or ZFS intent log. It's sort of like the redo log. When I do a sync write, the changes are what get flushed. I don't flush all these blocks to disk. And it's sort of like a DB writer. These blocks get flushed to disk in batches. The idea being that I'll change multiple data blocks, all with the same dependent metadata blocks, so that there's only a small percentage overhead for the metadata. And that's what we see on active file systems. There's about a 10% write overhead for the metadata. So how do we use these technologies to make thin clones? In this diagram, it's actually easy, pretty easy. I have my production instance with its LUNs on some production storage. And if this is EMC, ZFS, or NetApp, I can take a snapshot of it. Boom. Before I take the snapshot, I need to put this thing in hot backup, take the snapshot, take it out of hot backup. Once I have that, then I just have to clone the snapshot and export those clones over something like NFS so that they're visible from a target machine and start up Oracle on the target machine, pointing to those data files. And boom, I've got a clone. And I love it because I see on forums, oh, snapshotting is easy. Well, anybody see any problem with this? If this is a QA instance or a reporting database, which LUNs is it going to be hitting when it does its I/O? It's going to be hitting the same LUNs as your production database. What was the whole point of this exercise?
Not to do that.
Get the load away from the production database. So this easy stuff doesn't solve our problem. It probably actually makes it worse.
Well, just briefly, what we do is we mirror the snapshot to a separate file.
Yeah.
And we move the content of that.
So how do we do that? So somebody pointed out the solution is, I want to get production database copied to a non-production filer. Which storage? NetApp. So then I need to get a full copy onto a non-production filer, and then I can do the snapshotting. But what about if I want to get a copy, if I want to make clones tomorrow, do I copy the whole database again? That'd be sort of, besides, that'd be sort of creating the same problem I'm trying to avoid. I want to avoid keep copying this thing over and over again. So somehow I want to get the changes. I want to take one initial copy and then I want to stream in the changes. I don't want to copy this thing every single day. So how do we do that? So this idea of creating thin clones has like 3 components. One, I need to copy the source database to some non-production storage. That storage needs some snapshot technology. And then I need to be able to export that file system to a machine that's going to run the clone instance. I need to mount it, recover it, rename that database. So let's look at the different parts of this. First thing, how do I copy the source database to this non-production or storage? But more importantly, how do I keep it in sync? I don't want to keep copying this database every single day. So NetApp has a solution. Are you guys using this solution?
Yes, it's not mirror.
So I'll simplify this in a minute. Here's the white paper, TR-3761. You can read it. This is the proposed solution from NetApp. NetApp has a product called, I tried to make it easier because I couldn't read that diagram from NetApp, Snapshot Manager for Oracle, which will take snapshots of the source database. It requires another database, actually an Oracle database, to manage its changes. And with this, I can use another technology from NetApp called SnapMirror that will bring changes from the production array over the non-production array. SnapMirror needs Production Manager and also needs SnapDrive. And the biggest trick here is coordinating, because this has a schedule where it takes the snapshots of the database, and SnapMirror has a schedule where it's going to pull the changes across. So then you have to make sure these things are well coordinated. Once I have the snapshot coming in here, I can use the snapshots and use FlexClone to clone the snapshots and then start off with clones. How happy are you guys with that solution?
We actually don't have a Snapshot Manager for Oracle. Don't know what it does that. I guess it lets manage the snap mirrors transparently, whereas we just have local shell scripts too.
So you guys wrote shell scripts to do this?
Yeah. So for a big company, we had one guy who's really good. He built this great shell script, and it's wonderful. But for a small company, it would be a lot of work.
So you guys basically you wrote your own snapshot manager with scripts?
Yeah. And if you were to do it manually, this whole process would take a long time for sure. So,
That guy doesn't get you high less.
So it sounds like this is a smart guy that wrote this stuff.
He didn't call me up at 5 a.m. this morning to ask me some questions.
Okay, so that's half of it. After we get that data onto this file system, the other half is how do I create clones? I need to know how to mount these things. I need to share the file system. I need to know how to mount the file system on another machine. I need to know how to recover that database and rename it, change it into order parameters, which is a bit of work. Anybody can recite the NFS mount parameters by heart? I spent maybe 6 months beating on the things. They're not easy. Well, Oracle has a solution for you. It's called EM12C Snap Clone. I'm going to just go through the steps here. The one thing it doesn't, Oracle solution starts out with a thing called a test master database that has its data files on either ZFS, storage appliance, or NetApp. How you get your source database to the test master, I found no documentation from Oracle on how to do that.
Magic occurs here.
But once your test master database is here, here's what you do. You install EM12C, you install the snap clone option, you register the ZFS or NetApp storage with EM12C snap clone. You install some agents on a Linux machine in Linux and only Linux. Those agents are going to talk to the storage and do some operations on the storage for you. You have to register this test master with EM12C. EM12C will go try to map its data files to the storage appliance, make sure they're there. You've got to enable snap clone for that test master database, which allows EM12C to take snapshots on the storage. You've got to create these things called zones. So zone is mainly CPU limits and memory limits. And in those zones, you're going to put pools. So pools are sets of machines that you're allowed to create instances on. Then you're going to create a profile. A profile is a source database. In this case, the test master database has part of a profile. And then you have to create a template. And a template is a set of init.org parameters that are allowed for the clones. Once you've got all this set up, at that point, you can create an instance on a snapshot on that storage. And there's an interface that you can give. The reason you create all these zones and pools is so you can create a login that a developer can log in. He'll be limited to what he can do and what he can clone. But he can clone a database. So let's just step back. Where are we in the industry right now? I've got a production database that I've been copying full copies of into different teams. Where do I want to go? I want that production database to be synced daily or on a schedule to some non-production storage, and I want to share all the duplicate blocks in that non-production storage with all these clones. I've outlined two ovals here. One, the red oval, so this is the syncing, how do I sync with production? And then blue, how do I create those clones? We've got two solutions, one from NetApp to do the back end, one from Oracle to do the front end, and they're not compatible. Just be aware. So, what does it take to automate this thin cloning? I need a storage array expert. I think we've already discussed that here. I need special equipment. I need an EMC array, ZFS storage appliance, or NetApp, specialized equipment, and I need scripting. Because none of those solutions work together, which means I have to script. Again, let's go back to the people I mentioned at the beginning of the talk, CERN. They actually are a NetApp shop. They wrote over 25,000 lines of code so that they could allow their developers to have self-service, where they could go on and create a clone. So, the beginning of the talk was like, what a big impact copying data around has in the industry. It has a huge impact. There's a solution called thin cloning. Thin cloning's been around for 15 years. Well, if it's such a big impact in the industry and the solution exists, why isn't it used more prevalently? I don't see it used hardly at all. It's because the barrier to entry is enormous. Like, how do we break down that barrier to entry? I sort of think of it like, it's like the internet. The internet was around a long time ago. I mean, when I was in college a long time ago, in the 80s. I used the internet. I had email. There was Gopher. There was FTP. Did my mom and dad use it? No. Did my friends in psychology use it? No. Did my friends in computer science use it? Yeah. What happened when the browser came out? Everybody used it. So that's what we want to do to database virtualization. And that's what database virtualization is. Make it point and click easy. So just to review where we are and where we're going. So if I have 3 physical clones, they come into SAN, they all have their own copies of the data files. With what we're calling a database virtualization appliance, this is our goal, the nirvana. This is our internet browser. I have the 3 copies, they come into the data virtualization appliance. It orchestrates access to an array. There's only 1 copy of the data files. And any data that's modified by these clones, access to that modified data orchestrated by the database virtualization appliance, so only that clone can see what's modified. Nobody else can see it. So you have a couple of options. Oracle, we've already mentioned ZFS, but Oracle has a product called SMU, our Snapshot Management Utility for ZFS. I work for Delphix, so I'm going to talk a bit more how Delphix works. I haven't yet used SMU, although I read a good bit about it. SMU requires the ZFS storage appliance. It supports only 3 databases, Linux, Lars, and Windows. And it's a graphic interface. Once I have it installed, I have my ZFS storage appliance. I can take snapshots through the graphic interface, and I can clone databases through the graphic interface. With Delphix, what is Delphix? Delphix software installs in any commodity Intel hardware. It runs as a VM in VMware. We ship it as an ISO, start it up. It supports Oracle 9 through 12, supports RAC, single instance, standard edition, supports SQL Server. Once I install Delphix, it takes about 5 minutes for me to install a Delphix VM. I then allocate some storage to it. That storage can be anything. It can be MC, NetApp, JBOD. One of the coolest things is that storage can be flash. So the flash market's pretty new. Anybody using a flash array yet? 0. So it's new, but it's coming down the pipe fast. But who's going to win? I mean, there's Violin, there's Nimble, there's Pure Storage, there's Fusion.io. I don't have to choose. I can choose anything. I'm not stuck on it. I can hook up any flash array to Delphix and take immediate advantage of it. If that vendor loses out, I can hook up some other flash array to it. We actually just did, this is interesting, we actually just did a team joint test with Pure Storage. For 1/10 of the price of spinning disk, we got the same performance using flash with Delphix. Because we're sharing blocks, it was cheaper than actually using physical spinning disk without Delphix. And with Pure Storage, we got performance better than spinning disk. So after I install Delphix and after I allocate some storage to it, I can register a machine with Delphix. When I register a machine, Delphix will auto-discover any databases running on that machine. For SQL Server and Oracle right now, we'll be releasing Postgres very soon, and in the pipe are Sybase and MySQL. Once I register the machine, then I can choose to link to one of those databases. When I link, the first thing it does is it takes a full backup of the database, the source database. It only does this once and never does it again, and that backup is typically compressed by 1/3. After that initial backup is taken, then incrementally and forever, we collect the changes that come into that source database. So I have my initial backup. I incrementally collect the changes in what we call a time window. By default, it's 2 weeks, but it could be 2 months or 2 years, however you can configure it. And any data from that original backup that's aged out of the time window gets purged. And then when I want to start up a clone, it only takes a few minutes. I can spin up a clone on an instance. When that clone starts changing some data blocks, those get stored in Delphix, and all this is compressed. So we go from where we were, all these multiple copies of physical databases, to where we want, simplicity and speed. Changes coming in from the source database, and then all my clones share the duplicate blocks here. And any blocks that are changed by a clone are private to that clone. So the interface, I'm pretty psyched about it. So this is the interface of the product. As I said, I used to work in Enterprise Manager. I always wanted cool graphics. I had a hard time getting the graphics I wanted. One of our customers looked at this and said, if Apple had written Enterprise Manager, this is what it would look like. I'm pretty happy with that. So Delphix cuts through all that complexity. So just to reiterate the 3 steps, I have to sync with the source database, pull incremental changes. I have some storage that does the snapshotting and cloning technology and compression. And then I have automated in the software an interface, a simple interface that anybody can use. And 4 clicks of the mouse, I can spin up a clone database. So what this gives me is it gives me fast, full, fresh clones. It only takes a few minutes to make a clone. They're fresh. I can have these clones a few minutes behind production, and they're full. So where I used to have like a team sharing a single copy, a full copy of production database, now I can give every developer in that team their own copy of the database. So VDB is what we call a virtual database, VDB. So now I can parallelize development.
That's when Oprah gave away the code.
Not only can I parallelize development, I can parallelize QA. Maybe I just have one QA environment. Now I can have multiple QA environments, and I can build them fast. And again, the interface is built, we have an interface built for developers. So we have security, role access. The developer can log in, they'll see what he has access to see. We limit how many copies he can make, we can limit how much storage he takes. And in a few clicks of the mouse, he doesn't have to talk to a manager, he doesn't have to talk to DBA. He can create a clone database. Not only can he create a clone database, he can refresh or roll back the ones he's using. And we can do things that previously were unheard of. If I have the development team is working on a development database, and they've made some schema changes, and now we've got some code and schema changes, we want them QA'd. I don't have to build a QA database anymore. I just branch it. There's no copying of data. I'm sharing data. So when I make that branch, it's made in a few minutes. And then I can start queuing immediately. I don't have to wait for QA environments anymore. We can do things that were almost impossible before, like cloning federated databases. I never heard of the term federated. Anybody hear the term federated databases? One? This was new to me. The idea is an application that uses multiple databases. And if I clone it, I've got to clone the multiple databases all at the exact same point in time. Well, how do I do that? If those databases are owned by different DBA teams, it's a bit like herding cats. We worked with Informatica. They had consolidation projects. So they had an application that used 6 databases. Each database had a different customer's information in it. Each database is run by a different DBA team. So they expected to take at least 6 months to get a copy of each of those databases at the same point in time. They pulled in Delphix, and Delphix, you didn't have to coordinate with anybody. Here's just an example of 2 databases. They did 6, but I can pull in those databases anytime I want. One this week, one next week, one the next week. Once they're in Delphix, I can spin up a clone down to the second, so I can pick the same second across all 6 databases and spin them up. So that project that was estimated to take 12 months in Informatica, they did it in 6 months. The CIO, Tony Young, said, I felt like a hero. I pulled in the project in half the time. I earned more revenue for the company. I took that revenue and put it in innovation. I actually won an award from Ventana Research for this project. So now we've talked about the problems in the industry with full physical cloning. We've talked about the solutions with thin cloning and database virtualization. If we have database virtualization, how does it impact our company? So 3 things I want to talk about: development acceleration, quality of data, and business intelligence. So first of all, for DevOps, probably the most important thing is it drastically accelerates our development projects. So these are what we saw as problems before in the beginning of this talk are now solutions. So I'm going to step through each of these 5 quickly. We saw in the beginning where we're spending over 90% of the time building QA environments. Well, now that goes down to less than 1% of the time. So now, instead of spending 4 cents out of a dollar on running QA cycles, I'm spending 99 cents out of a dollar on QA. My efficiencies go way up on QA. And I don't know if you've ever had a test that you want to run, and you want to run the responses fast because you're a bit stressed about it. Generally, when I QA something, I want to know right away what the answer is. So with Delphix, if I end a sprint, I don't have to wait anymore. I can spin up a QA environment in a few minutes and start QAing. So that dependent code on top of a bug doesn't get written. I have less rework to do. If I have a development team sharing a single full copy of the production, I'm running into bottlenecks, developers blocking each other, I can parallelize that. I can give each developer their own copy. And more than that, I can also have merge branches. So all these developers are making changes, well, I can have another branch that we call trunk. They can merge in their changes and we can test out, do their merge changes work together. I can eliminate running subsets. So now I'm running full copies. So those bugs that made it in production, we eliminate them. And that culture of no, can I have database please, can I have database please is gone. It's now the culture of yes. The interface is so easy, and there's basically no overhead that I can let developers create their own clone copies. So that's DevOps. It has a huge impact on DevOps. But what about quality? I want to talk about three things: forensics, investigating problems, A/B testing, and recovery. So we talked to a online ticket vendor. They do things like sell football game tickets. So 60,000 tickets would hit the market. They'd see these bugs in their code that they'd never seen before, and then after the tickets started to sell, the bugs went away. The bugs are related to whatever data sets they had. So I've got a few choices. One, I can like hotline up to the developer and say, can you hop on production and start messing around and see what the problem is? I don't know about you, but I don't let my developers on production. The other thing is to let the problem go by and then try to restore the database from whenever that anomaly occurred. Restoring a database might take 8 hours or be a lot of work. Is it worth it to go study that problem? Well, if I have a virtual database and a problem came up yesterday at noon, today at noon I can say, hey Joe, I'm going to spin up a copy of the database yesterday at noon when the problem occurred, go investigate it. Now it's a virtual database, it's not production, and it represents the database exactly as it was when the problem occurred. So that's forensics. I don't know about you, but one of the most stressful things for me as a DBA is patching and upgrading. I mean, when I put a patch on, or especially on an upgrade, I'm sweating bullets, man. The whole thing could go and not come back up, or not run right. So how do I get confidence when I do patching and testing? If I have virtual databases, I can just spin them up, run the upgrade, things go wrong, learn how to fix them, throw it away, spin up a new one, upgrade it again. I can keep doing it over and over until I'm confident that when I put that in production, it's going to work. And I also put up QA testing here. Sometimes when I do QA testing, I have to do some initial setup. Maybe I have to obfuscate social security numbers or credit cards. And that takes time. And then I run some destructive QA tests. And then I have to rebuild the environment. Well, with a virtual database, I can obfuscate the data, run my destructive test, and I can just roll back to right after the obfuscation. I don't have to rebuild the QA environment. So I can QA fast. And then this is one thing I love too, A/B testing. I do a lot of performance work. But sometimes I want to do something like add an index or drop an index. But if I only have access to a production database, I can't do that. And even if I'm sure it's going to work in production, I mean, I'm sweating bullets. And that's big stuff on a production database. Here, say I have 7 different things I have in mind. I can spin up 7 different VDBs, virtual databases, add an index here, drop some indexes there, change the net.aurora parameter here, run the load test in all 7, keep them all, compare them. And when then I find what I want, then I can throw them all away. So A/B testing is really fast and easy. And this is really cool. Surgical recovery. So Comcast, 2 days after they installed Delphix at their site, one of the DBAs dropped the movie titles table on production. So Comcast does streaming video, right? 40 million subscribers couldn't stream video. That means lots of lost revenue to Comcast. Well, okay, they got DataGuard. Guess what happened on DataGuard? Boom. DataGuard's in sync with production. That table was dropped and get DataGuard. So their choice is go to a backup. Backup takes 8 hours to restore. They had just installed Delphix 2 days earlier. 10 minutes later, spin up a database, pulled out the movie's title table. I think that's pretty cool. And another sort of fringe benefit of this is we tend to back up production, but I'd say 50% of the sites I talk to when it comes to development databases, half the time they're like, oh, those are developers. Who needs a backup development database? But where do problems happen more often? I get a developer get a developer database, he's just going to screw around. Things get screwed up much more often than production. But guess what? Half the time they're not backed up. If those developers are using virtual databases, a fringe benefit is that they're always backed up as a virtual database. If a developer does some nasty operation, drops a table, screws something up, and he calls the DBA, I can branch off right before that happened and give him a new virtual database representing his database right before he did the operation. And then, say I get a corrupted data file in production, I can spin up a virtual database, I avoid doing the reset logs, and then I can copy that data file back into production and restore a corrupted data file in production. And one of the really cool things about the sort of backup strategy is I can save enormous amounts of history for very little space. So if we look at the top, this is the typical backup policy suggested by Oracle. On the weekend, I take a full backup, and during the week I take these incremental backups. But if I have to recover from here, I've got to apply all these incrementals. So every week, it's suggested that you take another full backup. And that ends up taking a lot of space. This is this top line here. But on a virtual database, I pull in a full copy once at setup and I never do it again. And that copy is compressed. Every day I pull in incremental backups. The way they work in Delphix, those incremental backups are immediately available as a full backup. I don't have to go through this merging process. That means I can access any of these in a few minutes. And also they're compressed. So let's just take an example. I have a 9 terabyte source database. Comes into Delphix, it's 3 terabytes, compressed by 1/3. So then the difference between Delphix and the original database is 6 terabytes left over. So I have 6 terabytes of storage before I can reach the size of the initial database. But it's not 6 terabytes. That's 6 terabytes compressed. It's 18 terabytes of changes. So I can keep 18 terabytes of changes before I even get to the original size of the database backup. We see typically 50 days of backup to the original size of the source database. The final thing I want to mention is business analytics, business intelligence. So we see a lot of customers who have nightly batch windows, where either they maybe do a refresh of a data warehouse, full refresh, or they do ETL jobs, extract, transform, load. And these jobs take a long time. So we've got this window where where users are generally off the system, we're impacting load on production. But as data sets grow, we're starting to hit our windows. And if maybe I'm doing my refresh once a week or my ETL once a week, if I miss my window, then the whole week after that, the business intelligence unit doesn't have any data to act on. How are we going to change policies in the company to earn more revenue? I don't know. I missed my data extract window. Well, what about companies going global? Like if I'm doing 2 time zones, then my window where nobody's on production, it becomes very small. How am I going to do my ETLs now? And if I go fully global, what does that mean? That means I don't have any windows. How am I going to do this? Well, you could use something like DataGuard, but if I open up a DataGuard database, it's no longer usable. I have to rebuild it. I can use Active DataGuard. Active DataGuard means I can open it up and use it. But on Active DataGuard, it's read-only. Most reports and ETLs create temporary objects. I'm going to do some sort of sorting, aggregation, extraction. I can't run those in Active DataGuard. So these don't really work. And if I'm pulling over a full data warehouse refresh on my network, my IT infrastructure, it's going to flood the infrastructure. So that sort of thing, as you use Mac trucks, and often happens on the weekend, the network just gets flooded with these backups, or ETL jobs. But if we look at the database virtualization world, after our initial backup, we're just pulling in the incremental changes. It's like little motorcycles on the road. It's hardly impacting the network. If I have data warehouse refreshes that I want, I can do them multiple times a day. And then if I want to do ETLs, I can use this copy and have ETLs 24/7. So I get rid of those time windows. Another thing about business intelligence is some businesses want to know questions like, if I ran this query today and then I ran it yesterday, what's the difference? What happened yesterday or the day before? It's called temporal data. It's very hard to do in Oracle. Oracle has some suggested technologies to do this, like Flashback Archive. But if I turn that on, I've got to turn it on by tables. It also limits what I can do with those tables. Certain EDLs are not allowed. It also impacts production. If I'm doing Flashback Archive, I'm actually creating more data. There's more work production has to do. With virtual databases, I can spin up a database anywhere in that time window, run my query, and see what happened to that query on that day. So we talked about fast refreshes, temporal data. One thing I did mention is confidence testing. Has anybody here had to change a huge SQL that was generated a report or something, some massive SQL, and you're like, did that change really work or did it break anything? How do you QA that stuff? I don't have any guaranteed way to do it, but if I have virtual databases, what I can do is I can spin up the database yesterday, run my report, and run the old report and compare them. And I can do that for the last 30 days. And I build up confidence that my change in the report is a correct change. So just to summarize the impacts on a company. First and foremost, it's a huge accelerator with development. We've had companies over double their project output. So one company, KLA-Tencor, they had 100 developers. They over doubled their project output. It's like taking 100 developers and doubling, having a team of 200. Quality, so I can do things that would be probably prohibitively expensive before. I can do forensics, A/B testing, surgical recovery, like recovering somebody does something bad on production, I can like immediately get access to it. And then BI, I get rid of those time windows. I can do multiple data warehouse refreshes per day. I can do ETLs 24/7. So instead of a culture of no, instead of constraining storage, which I sort of think as the foundation of a company, everybody play Jenga here. I pull that storage out, the whole company
Jenga.
depends on those applications. Build up a solid foundation, give everybody their own virtual databases. I think I got 5 minutes, so I'm going to talk about one other thing. Anybody ever see this slide? It's coming down the pipe. This is something called Pluggable Databases from Oracle. There's actually a talk, I think, after lunch that I'm planning to go to. But this slide, this is a marketing slide from Oracle. Pluggable databases are really cool. What they're saying is this machine has 20 gigabytes of memory. You got to take it with a grain of salt, though. You got to understand what Oracle's trying to get at. This gray here is like how many instances of Oracle 11 can I run on 20 gigabytes of memory? And they said they can run 50 in 20 gigs of memory. When I go to pluggable databases now share the background processes. Now they share a lot of the PL/SQL packages and stuff. A lot of the memory gets shared. So when I spin up a pluggable database, it doesn't take up that much memory. I think I save around 400 megabytes. So on the same 20 gigs of the machine, I can put, what they're saying is I can put 250 instances. That's pretty cool. Anybody see a problem here? I don't know, guys. I don't know how long people have been around Oracle, but man, I love Oracle. But I also know how to look at what Oracle's giving me and say, okay, let's see what's going on here. If I have 250 databases on 20 gigs of memory, if none of that memory is used for anything else but the buffer cache would be 80 megabytes. And we're talking about 1980s, 90s, whatever. That's a tiny buffer cache. How fast are those databases going to run? They're not going to run very fast. So what I decided to do is let's do an experiment. Let's take two physical databases on one array. They both have their own sets of data files. I can take, anybody here Swingbench here? I use Swingbench for this.
Yeah.
So it's a benchmark written by a guy at Oracle. You have multiple options. You can do data warehouse or OLTP or a few others. I did the OLTP benchmark. I created a 200 gigabyte database. So this had two copies of it, 400 gigabytes. I pulled one of those into Delphix, compressed it. On Delphix, I had 200 gigabytes of RAM, so pretty big RAM. And I ran these two databases here. And one of the cool things about Delphix is this RAM, not only do we share the blocks on disk, but we share the blocks in memory. So once one of these instances is loaded up, there's two instances. Once one of them is in memory, the other one immediately has access to the same database in memory. So let's run these two tests. Here's the physical disks. This is, I aggregate the TP, the transactions per minute. I sum up the TPMs for the two databases. And then I do the average of the latency for I/O. And then I ramp up the number of users. So what we see is after about 60 users, TPM actually starts to go down. There's so much contingent accessing those blocks on disks. Remember, this database has 100 megabytes. I didn't use 80 megabytes, I used 100, about the same. Very small buffer cache. So it's constantly having to get data from disk. As I ramp up the users, there's so much contingent on disk that I hit almost 300 milliseconds of latency.
Oops.
This is an EMC array. I have 5 disks striped together. So this is not a joke. On Delphix, you can't even practically see the latency. Remember this, I've got a 200 gigabyte cache on Delphix. So the stuff is loaded up in a cache. I'm hardly even hitting the array. And the two instances are sharing that cache. And then my TPM goes to the roof. Now, you might say, you're smart, well, you're caching and all, that's not fair. Well, I want to cache it. I'm going to cache it. So if I had 5 of these databases, 5 200 gigabyte databases, and I have an EMC array, I need a terabyte to cache it. They each need their own copy. How much does a terabyte of cache cost an EMC array? List price, $1 million.
Whoops.
Maybe you got a good deal with your sales guy. Maybe you get it for $500,000. To do that with Delphix, I need 200 gigabytes of memory on commodity Intel hardware. Cost me $6,000. So this might be one of the biggest storage consolidation plays in history. If we took, there's 380,000 Oracle customers. If they have an average of, say, 8 copies per production in non-production environments, and say those databases on average are 100 gigabytes, that's tiny, right? We usually deal with terabytes. Let's just, for the sake of argument, If each megabyte saved was an inch, we'd go back and forth to the moon 10 times in savings if they virtualized their databases. But of all, whenever we talk to Delphix customers, they're like, I don't care about storage savings. That really has nothing to do with it. Storage savings is just the tip of the iceberg. The real gain is agility, speed. We talked about Informatica. They half the time of the project. KLA 10 Core, they over double their project output. Iridium over double their project output. Macy's went down from 8,000 hours of cloning databases down to 8 hours of cloning databases per year. So it's those kind of gains that really get people passionate and have a big impact on the companies. So instead of being slowed down by the bureaucracy and infrastructure required to copy physical copies, accelerate your businesses with database virtualization. And that's the end of my talk. A little bit about Delphix. Delphix was founded in 2008. The CEO is Jed Yue, very interesting guy. He founded Avamar. Anybody use Avamar here? It's data deduplication. He sold it to DMC. It's over $1 billion in revenue. We're based in Silicon Valley, and we're used by over 10% of the Fortune 500, used by the Fortune 1, used by Facebook, eBay, Comcast. If you want to see demos of this stuff, I'll be at the Delphix table out there, and I can demo it live. Talk about portability. If you buy EMC or NetApp, you're locked into hardware. Portability, I've got Delphix installed on here. So I have VBox, two Linux machines, and then I have Delphix VM, and I can clone databases on my MacBook Pro. So thanks for coming today. Let me know if you have questions. I'll be at the Delphix table.